Let's see if we can write an equation for this relationship. And so to write an equation, the thing that we need to know is what is this rate of change? What is it increasing by? So let's get a few points here. So this point is 1, 9. So let's just go ahead and make a table here. XY is going to be 1, 9. This next point here is 2, 12. The next point here is 315. The next point here is 418. And my question is, can I write an equation for this? Now I know this is a non-proportional relationship. Even without knowing the rate of change, I know it's non-proportional. And the reason I know it's non-proportional is because it does not go through the origin. We've learned previously that a proportional relationship has to have a constant rate of change and it must go through the origin. Now this one might have a constant rate of change, I don't know yet, but I do know that it doesn't go through the origin. So not a proportional relationship, but that doesn't mean we can't write an equation for it. So let's try to write an equation. So the x is increasing by 1, right? From 1 to 2 is an increase of 1, from 2 to 3 is an increase of 1, and so on, going up by 1, piece of cake. Y is going up by 3. From 9 to 12 is an increase of 3. From 12 to 15 is an increase of 3. You get the idea. Increase of 3. So the change in y over the change in x is 3 over 1, which means the slope is 3. So my instinct then is to say that the equation is y equals 3x. But it doesn't look like that works, y equals 3x, because if I look at that very first column, if x was 1, I would have 3 times 1, which is 3, and my first point is 1, 9, not 1, 3. Interesting. So let's make a table here. I want to make an x column, or row, I guess. I'm going to make a row for what it would be if my equation was 3x, because that's what I thought my equation was going to be, is 3x. And then I'm going to make a row for what y actually is. So when x is 1, 3x is 3, but the actual coordinate is 9. So my equation I know is wrong, because my equation y equals 3x says that it should be 3, but it's actually 9. Okay, what about when x is 2? Well, if x was 2, 3x would be 6. But the actual y, when x is 2, when I go up and look at this graph, my actual coordinate was 212, so y is actually 12. My equation says 6, but the actual y is 12. Okay, what about when x is 3? Well, 3 times 3, so 3x would be 9, but the actual coordinate on the graph for 3 was 15. And then the last one I have is 4. 3 times 4 is 12, so my equation that I thought it was, my fake equation, 3x, says it should be 12, but the actual coordinate is 18. So there's clearly a difference between what I thought the equation was going to be and what the actual value is. What is the difference? How much is my 3x equation off by? And when you look at it like that, you can see that my equation is off by the same thing every time. What's my equation off by? Well, it's off by 6. If I took my equation, which is y equals 3x, and I added 6 to it, I would get the correct y value. So 3x is close. 3x is a part of the equation. But I need to take the x multiplied by 3 and then add 6. And that is actually what the equation should be for this non-proportional relationship.